All right, boys and girls, welcome back to the drive-through, sponsored as always by the deli. A special seated version of the drive-through today. Hungry? Stop by the deli. Make yourself a honey ham sandwich on harvest wheat with Havarti cheese and sweet hot mustard. All right, so this is just directly related to what you guys just did yesterday when we learned about classifying triangles and classifying triangles by their sides and classifying by their angles. One thing that I'd like to review from yesterday, because it always makes people stumble, is what is the definition of an isosceles triangle? Sushobith? At least two congruent sides. Okay, so you have to remember that. That makes an equilateral triangle a type of an isosceles triangle. And that means we're going to have a lot of always, sometimes, never questions on your test. Okay, so you have to be ready for that. All right, the theorems that we learned today apply more directly to proofs. I'm going to go over these theorems in a backwards version than the book has it. Okay, so the first thing that you learn, if two sides of a triangle are not the same length, then the angles opposite of those sides are not congruent. Furthermore, the larger side will be across from the larger angle. Okay, now, I'm not exactly sure why the book just refers to two sides. I'm sure there's a good reason, I just haven't really thought it through. But here's what I want you to understand, okay? Three-letter name in here. All right. If we have triangle SYD, and let's say that side SD is bigger than side YD, and side YD is bigger than side YS, well, hopefully your transitive minds kick in, and you understand that SD, even though it's not stated, SD is also bigger than YS. Does that make sense? All right, if we're given that information, what can we deduce about the angle? Which angle is the biggest? We can't name an angle with two letters, so angle Y or angle SYD. Angle Y is the biggest angle, okay? What's the middle angle? Angle S would be the bigger angle. Let me change my colors on my greater than or equal to sign, because otherwise that would be very confusing. You follow what I'm saying here? And finally, what's the smallest angle? Angle D. Now, you won't be using that theorem in a proof, but that's a really important theorem in geometry. Okay? So far, so good on that? Let's keep in mind something. If SD was 100, and YS was 10, and YD was 60, would we have a triangle formed? No. Because 10 plus 60 is smaller than 100. So you have to also, this is going to take you back to that triangle inequality theorem. Okay, so far so good? All right, now, these two proofs, we will have abbreviations for. Sorry, these two theorems. Okay? And they're very closely related. All right, so Theorem 20 says, if two sides of a triangle are congruent, then the two angles opposite from those sides are also congruent. Okay? What we will say in class, in our proofs, our reason for that will actually involve a picture. We will just write this: if sides then angles. Do you understand that reason? Okay? And theorem 21 is the converse to that. So what's the converse to that, since we're reviewing for our quarter test? Good. If two angles from a triangle are congruent, then the sides opposite from those angles are also congruent. Did I spell something wrong? Okay, and in a proof, we will write if angles, then sides. Now, something I really want you to understand. This is not true in other shapes. Think of it. Think of a rectangle. Are all the angles equal? Yes. Are all the sides equal? No. So it's not true for other shapes. It's only true for triangles. Actually, it's only true for polygons with an odd amount of sides. Whoa. Okay? Have a great day. Boom!